Hello and welcome to the end of section 2.5, where we're going to continue to use substitution to solve our differential equations. And so now what we're going to do is called a reduction to separation of variables. So if we have a differential equation in the form dy over dx is equal to f of, then some ax plus by plus some c, some constant, it can always be reduced to an equation with separable variables by means of a u substitution. So we have u is equal to ax plus by plus c, where b cannot be equal to 0. So example 8, we're going to solve the differential equation by using appropriate substitution. And so here we have dy over dx is equal to 2 plus the square root of y minus 2x plus 3. And so our function part is going to be the part underneath the radical, where we have y minus 2x plus 3 is going to take the form of ax plus by plus c. So we have some function on the right hand side, and we're going to make that ru. So we have u is equal to y minus 2x plus 3. And now we want to be able to substitute for that dy over dx, so we're going to take the derivative with respect to x on the left hand side. So we do du over dx, and so on the right hand side we're going to take the derivative, and so this would be some implicit differentiation. When we take the derivative of y, we've got to say, okay, we took the derivative of y, so dy over dx, because the derivative of y is 1, so 1 dy over dx, minus, we're taking the derivative of x with respect to x, so we don't have to explicitly say that, so it's just 2, and then that plus 3 is going to be 0. So now we have du over dx is equal to dy dx over dx minus 2. Let's go ahead and solve that for dy over dx. So we say dy over dx is equal to just du over dx plus 2. Now we have everything we need to substitute it. So dy over dx is just going to be, change colors, du over dx plus 2, and that's set equal to 2 plus the square root of y minus 2x plus 3, which is just the square root of u. Now again, if it's of this form, this is a way that we could try. Doesn't mean that this is necessarily always going to work, but it's just another method to try to see if it does work. And again, this has to be a first order differential equation. Alright, so I look to solve. We have plus 2 on both sides, so that will cancel out. So we're left with du over dx is equal to, we'll just say u to the 1/2. Now, we can solve this differential equation by separation of variables, and that's what we're trying to do. We're trying to make this equation a separation of variables differential equation so that we can go ahead and get our variables on the same side. So I'm going to move the u over to the left and get u to the negative 1/2 du. On the right hand side, it's just going to be dx. Now we integrate the left and the right. When we integrate, we're going to get on the left hand side, so we have u to the negative 1/2, so we're going to have 2u to the 1/2 is equal to, then on the right hand side we can say x plus c. Now let's go ahead and substitute in what we have for u. So we have 2 square root y minus 2x plus 3 is equal to x plus c. And, if you want to manipulate that, you can. You don't have to. Or we can divide everything by 2. We can square everything if we wanted to. And then, we'd be able to get the y by itself, but we're not trying to solve this explicitly, so we're okay right here. Again, you don't have to go further. You could if you wanted to, but once we have everything back in terms of x and y, and we've gotten rid of our differentials, we're finished, we're solved. So that's it for example 8 and how to do reduction of separation of variables, to separation of variables.